So now we're at question 7, part A. So for question 7, it asks, give the major organic product or products, missing conditions, or starting materials for the following reactions. Be sure to clearly indicate stereochemistry using dashes and wedges, etc., where needed. Drying in enantiomers is not necessary, but if your product contains more than one chiral center, make sure to clearly demonstrate its stereochemistry, or in other words, use wedges or dashes. So you're given a molecule, so it gives you R4-methyl-2-heptene. So using our nomenclature skills, we in RNS skills, we draw the molecule to start off, and then the best, I think, thing to do is to go through the mechanism a little bit, just to make sure. There might be a possibility that we have shifting, so it's always good to just start the molecule or start the mechanism, because we might miss it if we just predict the product without even going through the mechanism. So I like to go through the mechanism. As you can see, the double bond gets protonated, and we get protonated on this side. Further from this tertiary position, so that way we can have the carbocation right next to a tertiary position. Here we have a methyl group, so we can shift to get to a better position, since we're directly next to right next to a better position, so we can shift. So we're going to do a hydride shift. The way you decide what kind of shift you're going to do is you look at the place that you want to shift at, and you find the smallest thing that you can shift. So the smallest thing is hydrogen, so we know we're going to do a hydride shift. There's a little symbol for hydride shift. And it's kind of good to just show the hydrogen moving, being transferred from this carbon to the carbocation carbon. So now we have our carbocation on a more stable tertiary position as opposed to the secondary position, since we're asking for major products. Then, just to finish up the mechanism, your methanol adds in just like water does. It can either add in from the top face or the bottom face. This is a non-stereoselective reaction, since we have a carbocation, so it doesn't matter. I just drew them on lines because our final answer isn't going to be chiral anyways. So you get a partially positive charge that we need to get rid of. We want to regenerate our acid catalyst, since it's acid catalyzed. And so I took the HSO4 minus, since that's the conjugate base of our acid, which we deprotonated in this step. So deprotonated and got our final answer.